Hello, we're starting a new topic of substitution today, and we've got quite a few learning outcomes for the whole topic as usual. So we're going to get part of the way through these today. I'm going to actually do quite a lot of this today. So first of all, I understand that letters can be used as well as numbers in maths. You should have done some algebra already this year, but we will be recapping on our basic rules of algebra before we even do anything to do with substitution. We're going to look at various different words here. We're going to understand the word term, expression, substitute, evaluate and variable. And we're going to be substituting to find the value of a term and substitute to find the value of an expression. So in this lesson, we're going to get most of this done. However, in further lessons, we're going to make it gradually more difficult and we'll do lots and lots of practice. Okay, so when we are doing algebra in maths, we are using letters as well as numbers. Now, you might be wondering why I've got a picture of spots and horses, but I'm just going to show you how we can use letters in maths to represent actual situations. Okay? So what we can do is call the green dots G and the red dots R, and we can write down how many we've got. So here we've got 5 red dots, so I'm just going to write 5R there. Here we've got 3 red dots, and here we've got 2 red dots. So we can see that we can represent actual situations by using letters. And it would make sense, wouldn't it, now, to call, just a second, there we go, to call the green dots G. So say we've got 4G there, and 1G there. Now, when we're writing one of a letter in maths, we don't put the 1 in front of it because we don't need to. We know that G on its own means 1G, okay, 1 green dot in this case, okay? Now, we can leave that like it is, or we could say that altogether what we've got here is 5R, add 4G, add 3R, add 4G, add 2R, add G, if we wanted to. Or we could collect all the red ones together and all the green ones together. So remember when we've done simplifying before, we've been collecting like terms, which means put things together that go together. So if we put all the red ones together, we've got 5 red ones there, 3 red ones there, so that makes 8 red ones so far, and then another 2 red ones there makes 10 red ones. And then if we look at the green ones, so we've got 4 green ones there, 4 green ones there makes 8 green ones, and another green one makes 9 green ones. So what we can do is we can write down the full amount like this, all separate, but then we can simplify it to bring it down to something that's a bit easier to understand. So all together here, what we're saying is, in all these dots here, we've got 10 red ones and 9 green ones. Okay, now it doesn't matter whether we're collecting dots or horses or umbrellas or houses or whatever. What we can do is put things that are like each other together. So you might look at this and think, I've got 4 horses and 5 horses. Or you might look at that and think you've got 9 horses. And both of those are correct. You have got 4 horses and 5 horses, and you have got 9 horses altogether. So in algebra, there are different ways of saying the same thing. And we're going to look at our basic rules of algebra just now to remind us of the different ways of saying the same thing. So, if we've got A, add A, add A, so you can think of that as apples if you like. If you've got an apple and an apple and an apple, what have you got all together? You've got 3 apples, haven't you? So A, add A, add A is exactly the same thing as 3a. Okay, different ways of saying the same thing. Now, 5m. If you were buying 5 marker pens and you knew the cost of 1 marker pen, how would you find the cost of 5? You would multiply, wouldn't you? So 5m means 5 times m. Okay? If we want 5 marker pens, we don't say we want 5 times a marker pen. We say 5 marker pens, don't we? So 5m, if you see a number stuck to a letter like that, it means times. Okay? And the next one, we've got c squared here. Remember that 2 up there is called squared, and what it means is multiply by itself. So c squared means c times c, and c squared is how we say that out loud. And then the last bit, if we've got 2 lots of 3t, so 2 times 3t, if we've got 3t and 3t, what have we got all together there? Well, we can see if we put 3t and 3t together, so if we've got 3 Toblerones and another 3 Toblerones, then we've got 6 Toblerones altogether. Or if we've got 2 lots of 3 Toblerones, we've still got 6 Toblerones. So 6t is another way of saying 2 times 3t. So during our topic of substitution, we will need to understand the different ways of writing the same thing. Now, we're going to go on and look at some vocabulary, some words. Okay, when we've got individual letters, like A or B or M or X, they are called variables. And the reason for them being called variables is that their value can vary. Okay, if you think about it, the price of an apple in a shop varies depending on what kind of apple it is or which shop it is. So the value of individual letters can vary, so we call them variables. Okay, now when we stick a variable with a number, or if we do something to a variable, like we times it by something or we square it, if we've got something like 5a or 3b, they are called terms. Okay, and if you put terms together, you get an expression. Okay, so variables are the letters, terms are the individual bits where you get by multiplying a letter by a number, or maybe squaring a letter, but when you put them together with add and subtract in between, they become an expression. Okay? It's worth taking a moment to write this down so that you can remember. So if you're going to do that, pause the video and write it down. Okay, so what I'd like us to do now is sort each item into the correct box for us to help to learn what's a variable, what's a term, and what's an expression. So if you go back to what we've written down a minute ago, then the single letters are the variables. So, for example, we can pick up this x and drop it into the variable box. Okay, can you see anything there that's a term? Well, 4b, for example, is a term because that's a variable that's been mixed with a number. And then an expression, remember, is what you get when you put terms together. So let's just pick the closest one here. So 9f minus 2 is an expression. So can you sort the rest of those just now? So take a moment, pause the video and decide which box each of these variables, terms and expressions should go into. And there you are, that's everything sorted into the correct boxes. So remember, our variables are our letters, our terms are what we get by combining letters and numbers. And our expressions are what we get when we put terms together. Now, there's a couple of other things that we need to know the meaning of. That's value and evaluate. So the value of something is what it's worth. So sometimes we're told the value of a variable or an expression or a term, and sometimes we have to work it out. So the value of something is what it's worth. Okay, and if you're asked to evaluate, then you find out what it's worth. You find out its value. Okay, so a value, that's a noun. And evaluate is something you do, so therefore that's a verb. So they're related to each other. So value is what something's worth, and evaluate is finding out what it's worth. Again, it'd be a good idea to write those down. Now we're on to the actual topic of substitution now that we've looked at the meaning of variable, term, expression, value, and evaluate. So, if we are given the value of a variable, we can substitute. Okay? Now, substitution in normal language means swapping, doesn't it? If you substitute players in a football match, you're swapping one out for one in. Okay? The one that goes back in doing the same job as the one that's just come out. And it's going to be the same with our algebra. So when we substitute, we're swapping. Okay? Now we're told that x equals 4, and what that means is the value of x is 4. Okay? So you probably notice at this stage that I do my x's curly rather than like that. And that's to make sure we can tell the difference between an x and a multiplication sign. Okay, we'll see later on why that's important. So, we are told here, we know that the value of x is 4. So x is worth 4. Okay, so if we need to find the value of this expression here, x add 5, we know that x is worth 4. So we can swap out the x, we can swap out the x for 4. Okay, so instead of being x add 5, what we're actually working out is 4 add 5, because this x here is worth 4. Okay, so 4 add 5 is 9. So we have evaluated the expression x add 5, given the value that x equals 4. Okay, so we're going to do it with the next one. X take away 3. So remember, x is 4 because that's what we're told. We're told the value of x. So we're going to do 4 take away 3 because we're substituting that x for its value, which is 4. 4 take away 3 is 1. The next one. Remember, x is still equal to 4 because we haven't been told any different. So next, x take away 7. It's going to be 4 take away 7 because we're swapping out the x for its value, which is 4. Now, this goes back to our integers, doesn't it? Because if we do 4 take away 7, remember 7's bigger than 4. So on our number line, we've got 1, 2, 3, 4. And then we'd have 5, 6 and so on. And on this side, we've got -1, -2, -3, -4, -5 and so on. So if we start at 4 and move down 7, because we're taking away 7, remember you don't count the 4 as having moved because you haven't moved yet. So it's 1, 2, 3, 4, 5, 6, 7. So 4 take away 7 we can see is -3. Okay, now back to our rules of algebra. 3x means 3 times x. Remember, I told you that that means if the number and letter are stuck together, it means times. It means 3 lots of it. And this is why I write my x's curly, because otherwise we would have written 3 times x there. And what does that even mean? We don't know if it means 3xx or 3 times times. We don't know. It doesn't really make sense. So what we have to do is make it clear what's a letter and what's a multiplication sign. Okay? Now, so we're working out 3 times x. X is 4, so we're working out 3 times 4. And 3 times 4 is 12, because what we did here, remember, was we swapped out the x for a 4. Okay, moving on. Last bit here we're going to look at for substitution is 5x plus 1. So we've got an expression of 5x plus 1. So we're going to be swapping out the x for a 4. But first of all, let's check that we know that this means 5 times x plus 1. So 5x means 5 times x. So we're going to swap out the x for a 4. So what we're really working out is 5 times 4, add 1. So 5 times 4 is 20, add 1 makes 21. Okay, so each time when we're substituting, all we're doing is swapping out the letter for the value that we're told. So I would like you to try these ones by yourselves now. So pause the video and evaluate using y equals 3. So in these expressions and terms, the value of y is 3. So y is worth 3. So each time you're swapping out the y for a 3. So here you're working out 3 add 6. Okay, I'll leave you to get on with those and you can check your answers when you've done them. So there are your answers with the substitutions in. So I've put the 3 in each time and then worked out the value. And then I've just highlighted where all the y's are there and where all the 3's are. Okay, well done if you've managed all that. If you did, I'm just going to stick a couple of extra ones in here for you just now. So remember, we're still sticking with y equals 3. Oh dear, not with that kind of pen, we're not. So we're sticking with y equals 3. And I would like you to see if you can work out y squared. What would the value of y squared be? Can you remember what that means? Y squared means y times y. So we'd have 3 times 3, which would be 9. Okay, so that's as far as I wanted us to go this lesson, and we'll just recap where we've got up to, because it's really important that we can see that we're progressing through our learning outcomes. So first of all, I understand that letters can be used as well as numbers in maths, and we demonstrated that with the red and green dots and with the horses. I understand the basic rules of algebra. Do you remember those? That was A add A equals 3a. It was 5m means 5 times m. It was c squared means c times c. And that 3 times 2t is the same as 6t. So they were our basic rules. We looked at these words: term, expression, substitute, evaluate, and variable. So we've got a note of what they all mean. And we started substituting to find the value of a term. So when we had y equals 3 in the last set of examples there, or the last exercise you did, we started off with y equals 3 and we found the value of a term, such as 5y. So that would be 5 times 3, which is 15. So we did that, and we substituted to find the value of expressions, and that's what we're going to continue with next time, because the expressions need to build And we're also next time going to use more than one variable. Okay, so we will look forward to that. Well done for getting so far with this today. And if you've got any questions, remember and just ask your teacher. See you soon.